there are a couple things that we got to know about the Pythagorean theorem. First one has to do with C. And this is the source of most mistakes that people make with the Pythagorean theorem. And it's really, really important. When we're talking about C, C has to be which side of the triangle? Ooh, we don't know this one. That's all right. Here, you know what? Let's go ahead and draw a triangle next to this. And make sure it's a right triangle. There's a special name for the side of a right triangle that is across from the 90-degree angle. It's the longest side also. Starts with an H. Does anybody remember that name? You know what? You guys haven't heard this word before. How about HY? There we go. Hypotenuse. Hypotenuse. When we get into trigonometry in semester 2, we will be talking about the hypotenuse a lot. The hypotenuse is the longest side. It's the side across from the 90-degree angle. If this is the first time you've heard that word, maybe make yourself a note that it is the longest side and it is across from the 90-degree angle. The other two sides are sometimes called legs. So if we use the Pythagorean theorem, C has to be the hypotenuse. It has to be. And there's something else that's really important about the Pythagorean theorem. And it is that it only works for right triangles. So the second most common error with the Pythagorean theorem is people try to apply it to non-right triangles. If we got something that's not a right triangle, then we have to use some other more advanced math. You'll learn in Algebra 2 and spend a whole bunch of time on pre-calc. So in geometry, when we're analyzing sides and angles of triangles, we're going to focus on right triangles. And the tool that we're practicing and learning today is the Pythagorean theorem. So we're going to put a couple of examples in here. So Pythagorean theorem is useful when you've got a triangle and you know two of the sides, but you're trying to find the third one. So let me draw a right triangle. It's got to be a right triangle, right? Because the Pythagorean theorem only works if it's a right triangle. And I'm just going to make up some numbers here. Let's say this is 17. No, we'll go smaller numbers for our example. Let's say this is 8 and this is 5. And for one reason or another, we're trying to figure out what x is. So we're going to write the equation for the Pythagorean theorem. It's a squared plus b squared equals c squared. And we got to get the right things in the right place. And the key piece of information is whatever goes in this spot here must be what again? Say that word. Hypotenuse. Must be the hypotenuse. In this case, which angle is our hypotenuse? Or I'm sorry, which side is our hypotenuse? X is. X is the one that's across from the 90-degree angle. So our hypotenuse has to go in that spot. Now, as far as the other two sides, doesn't really matter which one goes where, because we're adding and we can add in whatever order we want. So if you put 5 here and 8 here, that's fine. If you put 8 here and 5 here, that's fine. I'm going 5, then 8, but if you reverse that, no big deal. Any questions up to here? Getting in everything in the right place is kind of the key step. From here, we just got to solve. So we'll do things one step at a time. I got exponents here that I can simplify. I'm hopeful that we know what 5 squared is. It's 25. And 8 squared is 64. And x squared, I don't know, so I'll just leave it as x squared. Well, it feels like I could simplify something else here. 25 plus 64, that's on the same side of the equation. We should be able to add those together. What is 25 plus 64? 89. Still have x squared over here. And I wouldn't normally do this in a separate step, but let's go ahead since this is our notes. Copy that down again for me. And who remembers how to get rid of a square on an x? What's the opposite of squaring something? Opposite of squaring something is square rooting. Square roots and squares cancel each other out. Kind of. And algebra 2 will tell you that that's only partially true, but for geometry, it's going to work 100% of the time. So when I take a square root, that cancels the square. Now I just got x equals, and then I just need to figure out what the square root of 89 is. Now I can't think of a number that multiplies by itself to get 89. So we're going to need our calculators. Get your calculators out, please. Let's make sure we know what buttons to hit to get our square roots. It's different on every calculator. On the majority of scientific calculators that I've seen, you're going to want to look for an x squared button or something squared button, and usually you'll see square root above it. Now, sometimes you're going to see a square root and then you'll see an x square root. We just want the square root. If the marking is above the button, that usually means you need to hit the shift or second key first. So for me to get this square root, I've got to go second. So just tap second and then tap that button, and that should give me a square root. And we're trying to take the square root of 89, so I'll type that in. And then hit enter. Now, if your calculator is really fancy like mine, it's just going to tell you that square root of 89 is equal to the square root of 89. That's actually good if your calculator does it that way. It's going to save you a lot of headache when you get to algebra 2. But if you want a decimal answer, there's usually a button on the calculator that means give me a decimal answer. On my calculator, it's just double arrows. So if you've got similar to a double arrows, for some people, if you do shift equals or second equals, that will get you your decimal answer. For today, we're going to be rounding our answers off to 2 decimal places. So 9 points. 9 points. Okay, now if I'm keeping 2 decimal places, I have to look at the third one. Am I going to keep it 9.43? Or am I going to go up to 9.44? So you got to look at the number that comes after the 3. And if this is 5 or greater, then you round up. But it's not. So we keep it as is. So 9.43 for our answer. If you're having trouble figuring out how to get square roots to work on your calculator, get my attention when we get busy on our work here, and I'll help you out with it. Okay, we're going to do one more example. Any questions on this one, though? All right, let's do it. standard generic looking right triangle. And let's go some big numbers this time. 42. Why not? That one's 42. This is 31. And this is X. Now I'll tell you that this is going to be the one that people make mistakes on. Oh, I need my right angle on there. You can't do this unless it's a right triangle. My Algebra 1 students always want to put the X here. They always want to put the X here, but we know that that's not right. What has to go in this spot? The hypotenuse has to go in this spot. The hypotenuse is 42. That's the one across from the 90. So the 42 has to go here. So the most common mistake is that people always think that the X always has to go in that spot, and that's not true. Sometimes it does, but sometimes it goes over here. In this case, the 42's got to go there. So the X and the 31 are going to be in these two spots. Again, it doesn't really matter which one you put where. I'm going to go X and 31 like that. So let's simplify. X squared, I don't know what X is, so that's going to have to stay X. I don't know what 31 squared is, but my calculator does. It's just 31 times 31. My calculator has a square button on it, so that'll make my life a little bit easier. 31 squared. If yours doesn't, though, you can just do 31 times 31. That's 961. Uh, 42 squared, I have no idea. I'll let the calculator do the work. 1764, 1764. My goal is to get X by itself. What would you do next? What would you do, Jackson? Subtract 961 from both sides. What a great idea. That'll cancel that there, right? So now it's just X squared equals whatever that is. I think I can pull that off in my head. Yeah. We're really close. We're just trying to get that X by itself, which means we got to get rid of the square. So let's square root both sides. And then we'll get X alone. X is about. I should use my little squiggles here instead of straight equals. Have you seen that symbol before? It means like approximately. X is not exactly equal to this, but it's approximately. We use that when we round. Square root of 803. Type that in your calculator. Let's see if we're getting the same answers here. My calculator is coming up with 28 point. Okay, now I got to think about this. Am I going to keep it 3-3 or am I going to go up to 3-4 this time? Because the next one's bigger than 5. The 5 are bigger, right? That 7 tells us to bump the 3 in front of it up. So 28.34. And there we go. Any questions? All right. So I want to go back and look at this homework problem that we did a second ago. Remember how we said we were kind of guessing at that 4.3? Let's see if we can be more accurate than that. That's 4.3 we think. Someplace where you got a little bit of space, you could do this in your packet or in your notes or on scratch paper or write on your homework if you'd like. I'd like you to redraw me just this little triangle sliver right here. And if you're doing it on grid paper, try and get it the right size. If not, just label how big it is. I noticed that it's 2 units long and 3 units tall. And it is a right triangle, correct? So we think it's 4.3. I'm going to call it X for right now. Everybody should be doing this someplace. So pick up your pencil, draw the triangle, participate in class, please. That's how you're going to learn. I would like everybody right now to set me up a Pythagorean theorem equation and solve it and come up with a better answer. I said 4.3. That was just an eyeball. Give me 2 decimal places on this one. If you don't have a calculator, you're not going to be able to do the last step, but I want you to do every step up to that. So draw this little triangle for me, set up a Pythagorean equation, and solve it. There we go. So make sure that your hypotenuse goes in the right spot. You should be thinking about what your hypotenuse is. Remember, the hypotenuse is the one that's across from the 90-degree angle. Make sure that goes in the right spot. Ooh, that's kind of tricky. I don't know. What did you get? Let's see. Okay, we'll get it set up on here and then I'll have it. We're doing that for it's not like. Yes. All right. We're getting this. We're getting this. You guys put your X over here. You put your X over there because that's the hypotenuse, and you put the 2 and the 3 in here and here. Or but maybe you had the 3 here and the 2 here, but that's okay because we're going to add them. It doesn't matter what order we add. 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. And then you got to take a square root of 13 to finish it off. My calculator says that the square root of 13 is 3.605555127.5, and there's more decimals after that. So the question is, do we go with 3.60 or do we bump it up to 3.61? 3.61 because we got a 5 after the 0. So 3.61 about. And I guessed 4.3. I was way off. Whew, that's terrible. Oh my gosh, I counted wrong, didn't I? I told you to be accurate. This isn't a height of 3, it's a height of 4. All right, let's fix this. My bad. If you got 3.61, you used my faulty information. My apologies. Let's fix it. So that's not 9. What should it be instead? 16. And 4 plus 16 is 20. So we're taking the square root of 20 this time. My apologies. Thank you for correcting me there. I like how you did that too. You didn't say like, because you got it wrong. You said, because I did it a different way. All right. Did you say you got 4.47? Okay. Oh, I was pretty close then. I said 4.6. That's okay. It makes me feel better about my guess, but a little embarrassed about my mistake. You guys will forgive me though, right?
I mean, nobody else.
No. So I have your bonus point. You corrected my mistake. Remind me when we get to test day. All right. So we're going to practice this a little bit. Oh, we got all kinds of time. That's fantastic. I'm gonna have you guys work on this sheet. It's gonna be part of your homework. So whatever you don't get finished in class, you're gonna finish up. There will also be a couple problems out of the book, and I'll put that up on the projector here in just a moment. There's not enough room to do most of these unless you write very small on the paper, but you can always flip it over on the back and use the back side, or you can do your work on a separate sheet of paper. Just wherever you put your work, make sure you hang on to it, because I'm gonna stamp you for this on, Friday. So some of them you've got a little bit of room that you can write if you kind of write small. I'm gonna work through one of these with you. You're welcome to ignore me and just gonna work on your own through it. But I'm gonna look at number one. I'll get some scratch paper next to it here so I can show my work. So they're asking us to find the missing side, so I'm just gonna put an X in here. And I'll write my equation. And let's see, where am I going to need to get? I need to get the right thing in this spot. That's got to be the X because that's the hypotenuse. So X goes there and 6 and 11 go there. 6 squared is 36. 11 squared is 121. $36 plus 121 is 157. And then I need to take a square root on both sides to get my X by itself. Square root of 157 is we're just going to go one decimal place for these ones. Looks like the answers are all one decimal. So 12.5, or should I bump it up to 12.6? So you got to look at the next number after the 5. If it's a low number, it stays at 5. If it's 5 or more, it bumps it up to a 6. This is a low number, so we'll leave it at 5. So 12.5 for answer for that one. Now, when you get an answer on this sheet, then you're going to cross it off down below. So I'm looking for 12.5 down here. Oh, there it is. So cross this off. Now you've got 7 problems on there, so you'll end up crossing off 7 of those boxes. And then whatever box remains will give you the answer to the riddle. The answer to the riddle is, how do you write a song that will knock over a cow? Lower your expectations for this joke. It's not going to be nearly as funny as it could be. These are usually pretty lame. So temper your expectations for the punchline. All right, you guys have some time to work on that, and I'm gonna add a couple more problems out of the book because I want to make sure we're practicing some of the stuff that's going to be on the test. I'm going to stop you with about 6 or 7 minutes left in class, and I'll go through and tell you exactly what's going to be on our test.